Okay, YouTube, in this video we're going to explore row echelon form, or the row echelon form of a matrix and the reduced row echelon form of a matrix and their value and writing things that way. So let's go ahead and visit row echelon first. Essentially, when we talk about row echelon form and matrices, we're talking about a matrix that is in this form where we have, say, ones down the main diagonal and we have zeros everywhere underneath, okay? And so this row echelon form, what you can see here is this kind of stair-step pattern. Now, this is wonderful row echelon form right here. I would say that they don't always look this pretty in row echelon form, and I suppose we could put in some values over here. How about 4 to -2, -1 to -1? I don't know. But this would be in what we call row echelon form, and one thing we do want to mention here is that we kind of abbreviate this with REF. So notice this, it says if you're in row echelon form, you have this stair-step pattern here with ones as leading coefficients. So it says any row of all zeros is at the bottom. We don't have a row of all zeros here, but it would have to be at the bottom if it's in row echelon form. And then we say all of the rows have the first non-zero entry equal to 1, okay? Lastly, for two successive non-zero rows. So as long as you're not both non-zero, we say the leading one in the higher row is farther to the left than the leading one in the lower row. So what I basically want to mention is we could have another matrix in row echelon form. You know, if I were to say that, let's take our original matrix here, and I say that this one right here is 0, 0, 0, 0, and that's at the bottom. And then here I get 0, 0, 1, and 2. And I just, I kind of just made this up here. But you could see how what we're saying here is for any two consecutive non-zero rows, these were both non-zero rows, the leading one in the row underneath has to be further to the right than the leading one above it. Or conversely, we would say that the leading one above the row below it has to be further left than the leading one below it. Okay, so looking at it this way, we get this stair-steppy pattern here, and this would also be in REF right here. So what we're also going to mention here is reduced row echelon form, and reduced row echelon form is absolutely my favorite form by far, because reduced row echelon form also maintains that you have ones down the main diagonal and zeros elsewhere, but it also says that you have to have something in this configuration here. So it doesn't always, just like this here, doesn't always look as pretty as this original graph that I'm trying to use to illustrate what reduced row echelon form looks like. But let's say I have something like this here, about 2, 3, 4, I don't know. Something like this here, this would be reduced row echelon form. And looking at why, it's because it's all of this stuff up here, but we say zeros are above and below every leading one. So you'll notice that we have zeros below this one, and I have zeros above and below this one, and I have zeros above this one. Basically, zeros everywhere except for ones down this main diagonal. So let's talk about the significance of writing things in row echelon form or reduced row echelon form. If you've solved systems before, then you're well aware that this augmented matrix right here really represents this system that I'm about to write, plus 2z equals 4. We will get no x's plus 1y minus a z is equal to 2. And then this last equation would just be z equals -2. So if I said go solve this now, I say, well, I suppose I know that z is -2. That's one thing that I'm instantly aware of. And also plugging that back in, just doing back substitution, you can see how back substitution is really easy here. We'd say equals 2. So this must mean that y plus 2 equals 2, that y must be 0 in this particular instance. So y is equal to 0 here. And if we actually go back now and plug these both in, y equals 0 and z equals -2 into the original equation, we would get x minus 0 plus 2 times -2 equals 4. In other words, we get x minus a -4. Actually, this would be minus 0. So x minus 0 is x plus a -4. So x minus 4 equals 4. Pardon me. So we get x is 8. So I'm going to go write this up here. But we'd say our solution to the system would be pretty stinking easy to find if we were able to write a matrix into row echelon form. Now, talk about the significance of row echelon form. Look down here. And what we're seeing is this. We get x is equal to 2. And we get 1y is equal to 3. And our system says that z is equal to 4. This reduced row echelon form would instantly give us the values of our x, y, and z just by looking at these values over here if we could put it in reduced row echelon form. So our goal is going to be to put matrices in this form quite a bit of the time. So as far as this system is concerned right here, just know that this is the same system that we started with over here and that we've already solved for its solutions right here. So where it says solve this system, you can transplant this information into this spot right here. Cheers.